All right, good afternoon, everybody. We are on the back side of homework 6, and as promised, this is going to walk you through the answer for homework 6, number 2, which is very similar to the test that you guys will be taking tomorrow. So as Darielle asked, I will try to go a little bit slower so you guys can pick this up as I am going through it. So we are going to take grams of sulfuric acid, and it's going to be added to sodium bicarbonate. So sulfuric acid is H2SO4, and we know that all acids are aqueous. It is going to be added, so that means it's going to be reacted to sodium bicarbonate, NaHCO3. And because I have a carbonate and an acid, that should tell you that you're going to have 3 products. So my 3 products are going to come from the sodium with the root of the acid, so it's going to be sodium sulfate, and I look up and sulfates are solids. Actually, it's aqueous because it's an exception, plus carbon dioxide, which is a gas, and water, which we know is going to be a liquid. And we should be really good at balancing now. And so when I balance this out, I have 2 sodium on the right-hand side, so I need 2 sodium on the left. I have 2 carbons now, so I need 2 carbons over here, and I have 2 hydrogen right here, plus 2 more right here, so that means I need a 2 out in front of the water. So go ahead and go back and read what it says, and it says that I have 10.5 grams of sulfuric acid added to 7.50 grams of this. And it's asking me for the first thing, what is a limiting reactant? So which of the reactants is a limiting? So the thing that you need to reflect upon is to remember that it doesn't matter what product I choose. So continue to read the problem. Here it asks for which is limiting reactant. B, it says calculate the masses of each of the products formed. And C, calculate the excess. Doesn't give us any indication of anything, so it really doesn't matter what your X is going to be. So I actually chose my X to be the water, only because we know the molar mass of that is easy to calculate. So your first step, take what is given, 10.5 grams of H2SO4 divided by its molar mass, 2 hydrogen, 1 sulfur, 4 oxygen. I add that all up and I get 98.1 grams per mole. Calculate that out. Make sure you're grabbing your calculator and doing this step by step so you don't get any calculation errors tomorrow. So I get 0.107 moles of my sulfuric acid. And I'm going to do unknown over known. So my unknown is 2 moles of H2O over 1 mole of my sulfuric acid. And then I'm going to multiply by the molar mass of water, which is 18 in 1 mole. Sorry, this is kind of getting stretched in here. And that's going to be 3.85 grams of water. So that's my first one. So all I've done is taken my 10.5 and run it through. Now I need to do the same thing with my 7.5. So I'm going to do 7.5 grams of my sodium bicarbonate. Same thing, divide by the molar mass. 1 sodium, 1 hydrogen, 1 carbon, 3 oxygen. Add that all up and I get 72 grams per mole. Do the math and I get 0.104 moles of NaHCO3. Now, some of you on your quiz, you stopped here and you tried to compare these two. You cannot do that. There are moles of different things. So I need to keep going and get it to the same product. So if I do my unknown over known again, I have 2 moles of my water to 1 mole of my sodium bicarbonate. Then I'm going to multiply by the molar mass again, which is 18 grams of water in 1 mole. This is quite a mess. I'm very sorry. And this is going to be 3.74 grams. So I'm going to look at both of these, and hopefully you're thinking to yourself, I'm looking for the smaller number. So my smaller number is 3.74 grams. So that's going to make this my limiting reactant equation. So what is my limiting reactant? Is going to be my sodium hydrogen carbonate. That's my limiting reactant. Now it says to calculate the masses of each of the products. Well, I already have the mass of my water because I calculated 3.74 grams. So this is 3.74 grams of this. Now remember we talked about today in class. Always go back to your limiting reactant to calculate the masses of the other two. So if this is my limiting reactant right here, I can start with that many moles. So I can say that I have 0.104 moles of my sodium hydrogen carbonate. Do unknown over known. So this time I'm just going to make my sodium sulfate my X, and you can see that that molar mass is 1, or mole ratio is 1 over 2, and that's sodium sulfate to 2 of my sodium hydrogen carbonate. And then I'm going to multiply by the molar mass of my sodium sulfate, which is 142.1 grams in 1 mole. So let me erase this a little bit right here. Get that out of the way. And I have 7.39 grams. So that's how much of that product I can make. Go back to my limiting reactant again. 0.104 moles. So I'm always going back to my limiting reactant times unknown over known. So my other product that I don't know is now my carbon dioxide. I don't know what that is. I can see my mole ratio is 2 to 2. So my moles are actually going to be the same. And this is CO2 to 2 of my sodium hydrogen carbonate times the molar mass of CO2, which is 44, in 1 mole. And that's 9.15 grams of CO2. So now I have them out for all 3 products. So this is the part that a lot of you had trouble with in class. The excess reactant. So it says calculate the excess reactant. Go back up to your equation. Let's look at it. So here's my equation, and we said that this is going to be our limiting reactant. Remember, we have to go back to that every single time. So this is going to be an excess. Make your excess your X. It doesn't matter that there's 10.5 grams there. We'll use that at the end. So my unknown is going to be my excess now. Again, limiting reactant I started with my limiting reactant there. I'm going to keep working with my limiting reactant. I hope I'm sounding like a broken record right now. As I have a couple people in here listening, they all agree. So I have that many moles of sodium carbonate. And my excess reactant is how many moles of that? So I have nothing written out in front here. So this is 1 over 2. So 1 mole of my excess reactant, which is H2SO4, to 2 moles of my sodium hydrogen carbonate, and I multiply by the molar mass of H2SO4, which is 98.1 grams in 1 mole. So this is saying I have 5.10 grams of H2SO4. Okay, now as we talked about in class today, this represents what we used or what we need to run this reaction. This is not the excess. So go in your bucket. How much do they give us? They give us 10.5 grams. I'm going to subtract what I need to run my equation, and I get 5.4 grams of excess H2SO4. So there's my answer for that. Okay, keep on going. If you are able to recover only 3 grams of the salt, what is the percent air? All right, what is the salt? So let's go back up to our equation. And the salt is, well, we have carbon dioxide. I know that's a gas. That's not a salt. I have water. That's a liquid. That's not a salt. So it must be this one right here. So again, how many grams of that? I have to go back to my limiting reactant. Broken record again. So if I take a look at Na2SO4, Do I have that calculated somewhere? Let's see, I should have that product somewhere, right here. So Na2SO4, this is the amount, 7.39 grams of that is my product that I figured out. So it's not very good chemistry here if we take a look at this. You need to remember that percent air. This formula will be given to you tomorrow on the test. It's actual minus your experimental over your actual times 100. So what I actually should have gotten was 7.39 grams. We subtracted 3 grams because that's what we got in lab. So this is like 7.39 is what we calculated in our stoichiometry lab of the copper we should recover. And back in lab you measured how much of the 3 grams you actually recovered. And then you calculated your percent air. We're doing the same thing times 100%. And that is 59.4%. Okay, theoretical yield, percent yield, all of that, that is not going to be on the test, so I will stop here on that so I don't confuse you anymore. Getting through letter D, like I said, is exactly or very, very similar to 24 points out of the 50 on your test tomorrow. All right, do the work today. It'll pay off tomorrow. Be a rock star. And I'll see you tomorrow ready for the test. Have a great night.